Greeting for panel and everyone. My name is Ting Singh and today I will present about my final year project with title of Study on Energy Efficiency using Building Information Modeling BIM at Shared Library Pagoh Higher Education Hub. My supervisor is Muhammad Shafiq Syazwan bin Mustafa and my co-supervisor is Fatima binti Muhammad Yusuf. We are from Department of Civil Engineering Technology, Faculty of Engineering Technology, University Tun Hussein on Malaysia, Pagoh campus. For the past few years, building in Malaysia, especially commercial buildings, have exceeded the standard of building energy consumption. In order to maintain thermal comfort of building under hot climate in Malaysia, air conditioning system became a basic demand which incessantly operating to fulfill comfort requirement for the occupants in the library. Regard to this, research on energy efficiency using building information modeling BIM software by simulating the energy analysis was carried out in order to increase the energy efficiency of the library. Mineral wool and polyurethane foam (P.U.F) are the materials which proposed to apply in existing wall of the building as the thermal insulation layer to increase the thermal resistance when the external heat transfer through the walls. The result of the building energy analysis simulated from Green Building Studio GPS is then being compared to identify the most suitable walls which are able to reduce the energy consumption of the library. Polyurethane foam, which is characteristic of high R value and low U value, obtain the most effective energy analysis which provide benefit of lowering the total energy consumption, total annual energy cost, and energy use intensity. The first problem statement is regarding rapid growing population and city development. The second one is the increasing of energy consumption in the building, especially commercial building. The last problem statement is regarding the high usage of air conditioning system resulted the excess consumption and energy wastage. Continue with objectives. The first objective of this case study is to determine the existing building energy consumption at Shared Library Pagoh Higher Education Hub. The next objective is conduct energy analysis at Shared Library Pagoh Higher Education Hub with different types of thermal insulation walls. The last objective is about to compare the energy analysis with existing building at Shared Library Pagoh Higher Education Hub. Continue with the scope of the study. This study will focus on the building energy performance data approach application of different thermal insulation materials on walls in the library by using the building information modeling models and simulation with Green Building Studio GBS. The significance of this study is to generate and analyze the energy consumption on the Shared Library Pagoh Education Hub with simulator in building information modeling software which prove that the application of the thermal insulation wall provide the impact of reducing energy consumption and increase the energy efficiency of the building. Based on previous study in literature review, the first one is Hassan in 2014. He stated that the buildings consume about 40% of total global energy, while commercial buildings recorded the highest energy consumption among the buildings. Next is Gilbert in 2019. He mentioned that there are 60% of heating load in commercial buildings flows through the walls, while the effective thermal envelope able to minimize the heat flow through building depend on the insulation wall. The last one is from Hong R in 2021. He also mentioned that when a building is insulated, The process of the heat flow through building cannot take place, and it maintains the temperature and reduce the use of energy on air conditioning. Based on the figures in literature review, it is the materials being proposed to become the thermal insulation layer in the building of the Shell Library Pagoh Higher Education Hub. The first one is mineral wool. Mineral wool has a medium thermal resistance, which has a medium R value, and it also is cheaper compared to other types of materials. The next one is polyurethane foam. Polyurethane foam has high thermal resistance, which is high R value, but on the other hand, polyurethane foam is considered much more expensive compared to mineral wool. Next is proceed to methodology. In methodology, the study was started from the building selection. The selected building of commercial building is Shell Library Pagoh Higher Education Hub. Then the data of the building information of the selected building is then collected and applied from the authority development of the building, which is the Science Derby. After that, the 3D model is then being prepared and drawn using Autodesk Revit. When the drawing of 3D model is finished, the building setting can be applied in Autodesk Revit, which consists of the settings such as location, weather, and energy. After that, the building analytical model of energy model is being produced. The 3D model and energy model is shown as the figure in the methodology. Next, the first energy analysis is then being performed with existing wall in Green Building Studio. The next step is to add in the additional layer of mineral wool and polyurethane foam in different models. Both of the models are being simulated, and the data is analyzed and also compared in the result and discussion. The last step is to identify the lowest energy consumption with the thermal insulation layer, and also considered as and selected as the most energy efficiency, which help to reduce the energy consumption of the library. Proceed to the results and findings. There are three categories of the data simulation of different types of wall from Green Building Studio GBS. The data which are total annual consumption, energy consumption, total energy cost, and energy use intensity as presented in table and figures as below. The manipulated variable of the data simulation is based on the type of wall, which including the existing wall, mineral wool insulation wall, polyurethane foam insulation wall. As we can see from the first figure, which is total annual energy consumption, the existing wall is recorded to consume the electric about 380,000 kilowatt per hour. The next is continue with the mineral wool. The mineral wool consume about 354,000 kilowatt per hour, which is recorded the second lowest for the electric consumption. The last one is polyurethane foam. Polyurethane foam is recorded the lowest electric consumption, which is about 294,000 kilowatt per hour in the total annual energy consumption, while the total annual energy cost in the second figure, we can see that the existing wall consume about the total energy cost of 139,000 of ringgit Malaysia, which is recorded the highest energy costs among the three simulation walls. The second one is the mineral wool. The mineral wool is cheaper than the existing wall, which recorded about 129,000 ringgit Malaysia of total energy cost. The last one is polyurethane foam, with its low total energy cost of 107,000 of ringgit Malaysia, recorded the lowest energy cost among the three types of the simulations. The last simulation table figure is about the energy use intensity. The existing wall consumed about, which recorded the energy use intensity of 147.5, while mineral wool insulation wall is recorded at 144.4. The last one is polyurethane foam insulation wall. It recorded the lowest energy use intensity of 121.7. In conclusion, among the three types of walls, polyurethane foam insulation wall has the highest thermal resistance, where it yields the best result in conserving energy efficiency of the library. The layer of polyurethane foam protects the internal cooling air by hardening the process of heat transfer through the sun into the external wall from the building. Not only that, it also slows down the process of the cool air escape from the outside. Its thermal characteristic shows that it has the best reducing the energy consumption in aspect of total annual energy consumption, total annual energy cost, and energy use intensity. That's all from me. Thank you very much.